Okay, so this is one linked question. A rigid beam is hinged at one end and supported on linear elastic springs, both having stiffness of K at points 1 and 2, and an inclined load X at point 2 as shown in the figure. So you can see the figure, hinge end is there on the left hand side. The angle is 45 degree, and basically this support is fixed. Okay, then there are two springs at point 1 and at point 2 equidistant, that is L and L, and an inclined load is applied. The magnitude is under root 2 P at 45 degree. Okay, so this is a question where two things we have to they have asked two questions basically. Okay, so I am showing you the question. Which of the following options represents deflections delta 1 and delta 2? So they have given delta 1 and delta 2, four options are given. And another question which they have asked is, if the load P equals 100 kilonewton, which of the following options represents R1 and R2 in springs at point 1 and 2? Okay, so basically they have asked us the to find the reactions. Okay, now let's see this figure and understand what concept is there. See, this spring is having some stiffness. Both the stiffness are same, both the springs are having same stiffness. Okay, so let us assume that the stiffness of spring is K. So let me draw, I will show you. First let me draw this and we will solve. Okay, so here you can see this is one support. Now this side is fixed. Okay, this side is, they have given it is fixed, and this angle is 45 degree. Now this is a hinge, this is your hinge. Now one rigid beam. Now understand that this is a rigid beam. Rigid beam means the beam itself will not deflect. Okay, its own deflection will be zero. So it is a rigid beam, and at the intermediate point there is one spring which is fixed at the bottom. Here also there is one spring which is fixed at the bottom. So the length is L, and this is also L. Okay, now this is point number 1, this is point number 2. Here an inclined load is acting. That inclined load is under root 2 P. Now this is also acting at 45 degree, right? So this is the question which they have given to us, and we are expected to solve it. Now in such type of questions, first we are expected to draw free body diagram. ठीक है, सो फ्री बॉडी डायग्राम कैसे ड्रॉ करेंगे? तो जितने भी सपोर्ट्स हैं उनको just we have to open the structure. Okay, so suppose this is my hinge point. So hinge point पे यहाँ पे कोई मोमेंट नहीं होगी. ठीक है, so there will be no movement, only some reaction will be there. Vertical reaction, let's call it RV, and horizontal reaction, let's call RH. Okay, same way there will be some reaction which is offered by this spring. Okay, so there will be some reaction here also, there will be some reaction offered by spring, because here there is an inclined load. Now this inclined load under root P, okay, that we have to resolve. ठीक है, रिजोल्यूशन ऑफ फोर्सेस से हमको देखना है कि ये कितना होगा, हॉरिजॉन्टल कंपोनेंट एंड वर्टिकल कंपोनेंट, हाउ मच इट विल बी. ओके, सो जस्ट you can see that this is your, here I am drawing, okay, magnified view. So suppose this is under root p, okay. So let's resolve like this. One is downward force and one is horizontal in this way, okay. So basically this angle is 45 degree, 45 degree is this angle, okay. So this is your horizontal component and this is your vertical component of this 45. So let's take vertical component as x, okay. So sine 45 we know it is 1 by root 2 is equal to opposite side, that is x, upon this hypotenuse, that is under root 2p, okay, because this is under root 2p, this portion, okay. So basically what will be x? X is equal to p, okay. Same way cos 45 degree, cos 45 degree is also 1 by root 2 is equal to, suppose now this is x, suppose this is x, or y, let's write y. So it will be y upon under root 2p. So again here also y will be equal to p, root 2 cancel. So basically here you can see both the horizontal component and vertical component are p. This is vertical also p, okay. So here we are having two reactions. Now let's understand the concept of stiffness. See, here the stiffness is K and here is both the springs are having same stiffness. So what do you mean by stiffness? I am writing here stiffness is equal to action upon displacement. Okay, action upon displacement. So either it will be K, it is denoted by K. So K is action, it may be either any force. Action means force and displacement means your deflection. It will be deflection, or even it can be action, may be moment also, okay. So moment is also action and that is displacement will be rotation or slope that is theta, okay. So here we have to see K is equal to force upon deflection, okay. Now force, here you can see what is the force. Basically force is the reaction, this is the force, reaction itself is the force, okay. So force will be K into delta. Suppose I am writing deflection as delta, so force will be K into delta, right. So here at point 1 the force or reaction will be K delta 1, because this is point 1, this is point 2. So here also reaction will be K delta 2 by this logic, okay. So many times we get confused, but we have to go by fundamentals, that how this force is equal to K delta, because we know that stiffness is action upon displacement. So force upon deflection, so force will be K into delta. So force is our reaction, that is reaction at point 1 is K delta 1 and reaction at point 2 is K delta 2, because K and K both are equal, but delta 1 and delta 2 are not equal, okay, because there is a difference in the distance, okay, L and L, okay. So now because of this upward reaction there will be some downward deflection, because see this bar or this beam is horizontal, beam is rigid, okay. So it will either go up or down in equal distance, okay. So only this deflection will be seen in the springs, respective springs, okay. So it will remain straight only, okay. It will not bend like this or like this, it will not deflect, okay, because this bar itself is rigid, okay. So now suppose this K delta 1, this force I am applying in downward direction on the spring, okay. So suppose this is your spring, so K delta 1 is going downward, same way this force K delta 2 is also applied to this spring. Is it okay? Now because of this K delta 1 force and K delta 2, there will be some deflection in spring 1 and spring 2. Okay, and this point is hinged, so it is fixed. Okay, so I am drawing over here. You can see this point is fixed. K delta 1 point will be somewhat, it will be deflected by delta 1. Here also it will be deflected somewhat over here. This is your delta 2. Okay, let's join these points. So you can see this distance is L, this distance is L. For L distance your deflection is delta 1. For 2L distance from the hinge, this is your hinge point. 2L distance from hinge, your deflection is delta 2. Okay, now by using the principle of similar triangles, okay, suppose let's name the triangle A, B, C, D, E. Okay, just I have named this triangle. So triangle ABC is similar to triangle ADE. Similarity of triangles. So can I write that L upon delta 1 is equal to 2L upon delta 2, right? So this linear equation L upon delta 1 is equal to 2L upon delta 2, this will LL cancel, so it will give the relation between delta 2. So delta 2 cross multiply, so delta 2 is equal to 2 delta 1. Okay, so I have got the relationship between delta 1 and delta 2. Delta 2 is equal to 2 delta 1. Okay, so almost delta 2 is double of delta 1. Now just see, this is your hinge end. So we are having all these forces RH, RV, okay, K delta 1, K delta 2, this P. Okay, so we can take moment about point hinge point, and we know that moment about the hinge is always 0. So these two forces are passing through this point, so we can neglect these two forces, and by just I am writing down, now taking moments about hinge point. Okay, about hinge point. So what will be the answer? See here, K delta 1, it is going in clockwise direction. I am putting my finger here. So K delta 1 into L, again this K delta 2 into the distance is perpendicular distance is 2L. Okay, and this P which is in horizontal direction, it is passing through this point, so it will not be counted. Perpendicular distance is 0, but this P vertical component, it is going in anti-clockwise direction. Okay, but and the distance is 2L. So what I can write? I can write K delta 1 going in anti-clockwise direction into L plus K delta 2 into 2L is equal to P into 2L. I can easily write. Okay, so let's take, see, L we can cancel from all the side. Okay, so let's take K common. K delta 1 plus delta 2, delta 1 plus 2 delta 2. Okay, 2 delta 2 is equal to 2P. Now just substitute the value of delta 2. Okay, so K delta 1 plus 2 into delta 2 means 4 delta 1 is equal to 2P. Therefore 5 delta 1 K is equal to 2P. So basically delta 1 is equal to 2P divided by 5K. I have got the answer of delta 1. same way just I substitute into the value of delta 2. Okay, so I will get the value of, if I am putting delta 1, okay, so delta 1 just I have to put it in the equation. So what I will get, delta 1 is equal to 2p upon 5k plus 2 delta 2. So I will get 2 into 2, 4p upon 5k will remain as it is. Okay, sorry, delta 2 is 4p upon 5k, this is delta 2. Okay, so I have got both the delta 1 and delta 2, okay, by using this formula. So just we can see the option delta 1 2p upon 5k. Okay, you can see here delta 1 is 2p upon 5k and delta 2 is 4p upon 5k. Yes, so answer, first answer we are getting, that is your answer is B. Okay, they have just told us to find the delta 1 and delta 2. So we have found out this answer. Okay, now what they are asking, now they have written that if the load P equals 100 kilonewton, which of the following options represent forces R1 and R2 in the springs 1 and 2. Okay, so here we have seen that this is your delta 1 and delta 2. Okay, delta 1 and delta 2 we know, but at the same time now they have given the value of P is equal to 100 kilonewton. Okay, P is equal to 100 kilonewton. And what was our reactions? What was our reaction? Our reaction was K delta 1 and K delta 2. Basically our reaction was K delta 1. So R1, I am writing here, R1 is equal to K delta 1 and R2 is equal to K delta 2. Now just we are supposed to find the value of R1 and R2. So R1 is equal to K delta 1, K into delta 1 we have found out, just delta 1 is 2p upon 5k. So 2p upon 5k, k cancel. So 2 into p is your 100 divided by 520, so it is 40 kilonewton. Okay, same way K delta 2. So K delta 2, that is K into, what is delta 2? Delta 2 we just found out, delta 2 is 4p upon 5k. So it is 4p upon 5k, k cancel. Okay, so don't worry that k is not given, k will be eventually get cancelled. Okay, so it will be 4 by 5 into 100, 520, so it is 80 kilonewton. So R1 and R2 we are having, we have got the answer. R1 is 40 kilonewton, R2 is 80 kilonewton. Just check the answer. So answer is here, you can see R1 40 kilonewton, R2 is 80 kilonewton. Okay, so answer is D. So thank you very much.